quickly go through what are, software supply chain attacks. There is a bit of confusion in people's minds as to what really constitutes a software supply chain attack. People try and, give various, meanings and attributes to this attack, forgetting that it's very different from the normal infrastructure attack. We'll see what that is. What is the current threat environment? What are the emerging, regulations and standards related to these, the software supply chains? After we go through the environment, we'll quickly go through attacks. What is the anatomy of a software supply chain attack? What are the sequences? What are the next generation software supply chain attacks? And we will cover the top three, in fact, which accounts for almost 97% of the software supply chain attacks today. That's discrepancy, confusion, type squatting, and malicious injection. After that, we'll see how we can mitigate these, attacks, both from the perspective of a supplier, because some of you all may be CISOs of supplier organizations, some would be of customer, thing to consume that. So how will a customer mitigate and how will a supplier mitigate these things? And then we conclude, maybe then have question answers. Now, the first thing, let's start by what is a software supply chain attack. This attack has to have a combination of at least two attacks, right? Now, that's the defining difference between a software supply chain attack and the normal attacks, like APTs and others. It's a combination of at least two attacks. The first attack is on a supplier, and then that attack is leveraged to target and gain access into the final customer or another supplier. So there are two distinct attacks, right? Therefore, the first important point is for an attack to be classified as a supply chain attack, both the supplier and the customer must be targeted. Next, there are four key components which make a supply chain attack. And that is the supplier who produces the software, the supplier's assets that are used to produce the software. Now, why this is important? Because assets are the ones which get attacked. And we'll see in the course of this presentation how these attacks occur and how they can be mitigated. Then you have the customer who consumes the software, and very importantly, the assets that these customers have, the valuable assets owned by the customer. In a software supply chain attack, the attacker's end objective is very clear, and that is to gain access to the customer's assets. He goes about it indirectly through the supplier, but the end result is that he wants to get to the valuable assets owned by the customer, which could be, the customer data. Excuse me. Sorry. So, the personal data, employee records, IP, financial data. So that is what the attacker wants to get. This whole, charade is to get to that assets. Now, what is the threat environment? Very clearly, these attacks are a difficult and growing problem, as Rahul and Murtaza and all have, already mentioned. But what is very important to understand is that vulnerability management is not the solution to these attacks, right? As Gartner says, no amount of vulnerability management can prevent these attacks. Like typically, VM is the bread and butter of cybersecurity. You put in place an excellent vulnerability management program in your organization, and you can stop most of the current attacks, not supply chain attacks, software supply chain attacks, right? These attacks are very similar to APTs, but they're even more complex. They're targeted like APTs, costly, a lot of planning that goes in. They take months to succeed. SolarWinds, the solar things, etc., took 9 months, right? And they go undetected for a very long time. And as Rahul had mentioned in his opening speech, 50% of the attacks today of these ones are attributable to APT groups. That means they are a very advanced attacks, right? Now, the important aspect of these attacks is that however good an organization's defense is, right? It could be excellent. They will still get attacked, right? There are victims include Apple, Microsoft, the best of the best. They all got thing. And these 35 of them have got attacked after SolarWinds, right? Despite knowing, how these attacks are occurring, 35, that includes IBM, HP, and Apple, they all got nicked after SolarWinds, right? So that's another defining thing. And it's very dangerous because the impact is an extremely large number of customers. Everyone who makes use of the affected supplier's software, all of them are going to be hit, right? And can't be stopped. And as Rahul had said, the thing is growing year on year, 650%, right? This is that Sonatype's, study, which is a pretty authoritative study on, software supply chains. Now, we will see why this sudden spike, and this is what we come into the next generation, supply chain attacks, software supply chain. So now when this is the environment, obviously, governments and the world as such have woken up to this, right? Because there has been an absolute, diminution of confidence in ICT products worldwide. And that's why there's been this massive emergence of regulations and standards in the last 8 months, right? It started with United Nations. Right from United Nations, they put up a report and they advised nations to establish policies, right, for adoption of good practices so that, internationally, there would be confidence in the integrity and security of ICT products. Is right at that, the United Nations GA, General Assembly, their resolution, right? US, February, they came out with a normal presidential order for supply chain, right? Based on that, the DoD came out with the Zero Trust Reference Architecture for Supply Chain. It's an excellent document. I would, recommend this for CISOs to go through this particular thing. Very neatly written, and it's an implementable architecture, reference architecture, right? Then NIST came out with, a secure software development framework in April, right? Then in April 21, they came out with another document, which is, defending against software supply chain attacks, which is again pretty thorough and good, deep, this thing, the thing where they give best practices, detailed best practices. Then in May, there was another presidential order which said that, these things have to come into place and organize all these suppliers. They've been given time till May 2022 to get themselves, compliant to these regulations, right? The first thing is, if they don't do that, they will lose out on all federal, orders. this is actually following the same trajectory that cloud, providers were subjected to, like where FedRAMP came up, right? Similarly, this one. Now, it's good for all of us because an imposition of this kind is going to get suppliers like on their toes, right? And they will have to implement, a whole lot of security thing, which we will see in the next slide, what those are, the crux of them, right? UK is come out with their own things. They've added software supply chain protection as part of their national cybersecurity strategy. Germany has come out in May 21. India, right, is now contemplating pretty seriously because we have been hit. Air India was completely trounced by software supply chain attack when Sita got hit. Air India's internal networks got completely compromised, right? Now Aadhaar APIs are out there in the open source things where people that's another area which which is getting attacked, this thing. So given these two things, India is seriously talking, and similarly many countries are looking at this. So it's a global the trajectory towards compliance and towards protecting organizations against the scourge of software supply chain attacks. Now, what are the main areas that these compliances are looking at? I've just compiled the main stuff from there. There are four crux of them. They all say that suppliers, right, who develop software, right, they must maintain a secure environment, right? They need to have separate builds, build separate environments for testing, staging, and then production. When a software is developed, it first is put into a staging environment. From there, it goes into the testing environment, and then finally goes into production. Then they all are supposed to implement the secure software, development life cycle and end-to-end pipeline protection. We will see in this presentation a little later what are these things. And these are my experiences, which I have implemented in Nissan, right? So you'll see some automation and other things that we had put in Nissan for pipeline protection, right? Then there has to be multi-factor risk authentication, and identity is very important because these guys get into the build servers and the CI servers to tamper with the software. Data should be encrypted. All alerts should be monitored, and very importantly, these compliances have consistently said that now a customer, right, has got the right to ask for artifacts that prove that the supplier is following and conforming to proper security practices, right? Earlier, it was like a black box. It was if you look at the good old days of the cloud, where nobody knew what these cloud providers were doing, right? And you wanted to audit them, they refused. They would not let you get into their thing, right? Similarly, software was a black box until these now compliances that are now going to hit by May of this year, right? All of them will have to start parting with artifacts and proof that they are complying with those processes, right? Very importantly, the second thing is bill of materials. A software is actually composed of number of components, and nobody knows. Customers definitely have no idea what they are of. And then one component of that may have a weakness, or it may not be patched, like the famous case of Equifax. What's that? Oh my God! Equifax, that the Adobe struts component, unpatched thing they had of that, which brought down that whole organization. So it's very important, and the compliance now says that providers will all software developers will provide a software bill of materials, which gives detailed composition of the software, and it has to be machine readable too, right? That's what the compliance says, right? Second, it requires them to deploy automated tools, because manually it's not possible. With agile models of development, right? Where things are getting developed every week, new softwares coming out there into the production systems. Things have to be automated, and they're enforcing suppliers to put in place automation. We will see this automation. Of course, now it's getting compliant. It's becoming regulated. But then, most of the large organizations, like I had a lot of automation in Nissan, Similarly, now it's become compulsory. You need to have automation out there. Second is that, you need to have controls over and audit and controls, right? Now, nobody really knows, including suppliers, and it's incredible, right? That where has the software come from? They're all in open source. You just pick that and plug it in. It might come from an attacker. It might come from a good person, right? So provenance means the origin of that open source and proprietary software. That needs to be maintained now compulsorily. That means if a supplier uses a component, they need to document that this component has come from this place, and we give the assurance that it is bug-free, it's vulnerability-free, it's Trojan-free, and maintain and perform. So these are basically the regulatory compliances that are coming by the thing. Now let's see these attacks part. That's the environment. The anatomy of these attacks. Okay. What is the sequence? First we start by sequence, and then we'll see the vectors, and then we'll see how they can be mitigated. The sequence is very clear, right? An attacker attacks or compromises one or more, supplier's code, right? The one which is in italics in red is what the report says. That's a Software Supply Chain 2021 Sonatype report. Normally what they do is they compromise these software build tools like Jenkins and other things. They're build tools. They are in SolarWinds, this thing, the build server was compromised, and it's kept putting in the sunburst malware with every build, right? So compromising building tools, undermining code signing, because today the only way a customer gets assurance of software is when he sees that the software has been signed by the supplier, right? But now what happens is that these guys steal the certificates of the suppliers and they sign a malware itself, a Trojan application. So it's completely undermines code signing. They hijack updates. Updates are being put out by the suppliers. They hijack it in between, insert malicious code, and then let the updates go out. And then they compromise open source. So 66% of the attacks have been focused on supply code to compromise, right? And then they use these compromised suppliers, the attack, this thing, to attack the final target, right? And now in this, attacking the final target is basically taking advantage of the trust relationship that the customer has with the supplier, right? You buy software from a supplier, you buy a software from IBM, right? This thing, you will trust that whatever updates that come up from IBM related to that software is okay. So you got to trust there, right? You trust automatic updates, you trust code signing from that supplier, and you trust backups, automatic backup. That is what is being, and 62% of the attacks have taken advantage of this trust into the thing. Next is by taking this advantage, they get into this thing and they gain privilege and persistent access. The importance, the underline is persistent. It's like an APT. They're there, and they're prowling in the network, with the thing, right? And this thing, the gaining of the persistent access can be through phishing, drive-by, but 60% of the cases, malware was the attack technique, which was introduced in the automatic updates or other malware or other software, which is downloaded in trust by the customer or the supplier, right? And then generally, additional tailored malware packages, to do specific things like stealing cryptocurrencies or, they are introduced. And then finally, right, the attacker gets right down to the assets and the resources of the customer, and they can do a lot of things. Data theft, financial theft, monitor. 58% of the supply chain attacks, software supply attacks aimed at gaining access to data, customer data, personal data, intellectual. The financial attacks is stealing cryptocurrencies, hijacking bank accounts, money transfers, and using networks and systems for conducting global DDoS attacks or sending spam. Now, this is where the software supply chain attack sequence is there. Now, what are the vectors? If you look at this, there's a supplier infrastructure and a customer's infrastructure, right? Now, basically both these infrastructures are the same, on-prem and cloud infra, which is systems, networks, applications, data, and users. Both of them are same. But supplier has got one more environment within their infra, and that's the software development environment, right? Now, the attack vectors, the doors are symbolic in this slide. That means the attacker can get into the infra. On-prem and cloud infra is a traditional, typical, perimeter attacks, application attacks, and other things, phishing, etc. Right? That's one way that they get in. Right? The other is that directly attack the software development environment of a supplier organization, right? And getting into the dev environment to compromise the build servers and tamper with the code. We'll see that how that is done, right? And how that can be protected. And it's for this reason that you need DevSecOps and you need pipeline security, right? Without DevSecOps, a supplier organization or any organization that develops software, right, is bound to get attacked, right? Now, these are the basic vectors there. Now, the controls on this is you bring in DevSecOps, robust DevSecOps for the software development environment that's out here, right? And stop this guy from getting in. Implement zero trust architecture for your infrastructure, which both the customer and the supplier does that. But in addition to that, the customer is also supposed to implement a robust supplier risk management. We will see what are the components of this supplier risk management. So zero trust architecture for infra, on-prem cloud infra, and supplier risk management needs to be put. And this is the CISO's job to see that this is done and put in place. Now, the thing is that while these are the vectors and controls, but these guys, the attackers have got smart. They know that organizations are plugging in these holes, and it's making it very difficult through a good implementation of zero trust architecture can actually completely finish off most of the lateral movements and attacks, right? Similarly, a well-implemented DevSecOps can protect the environment, dev environment pretty neatly. If these two things are done, it doesn't leave much scope for the software supply chain attackers. So what they have done is, right, they started moving upstream. Typically, what they were doing was that, this Equifax, as I was mentioning, that 2017 Struts incident. So they used to look at this part, the open source repositories. If any of them have got vulnerabilities and they're not patched, right, they used to then attack, they used to leverage that to get, to breach an organization. That is publicly disclosed open source vulnerabilities that are left unpatched was what they were leveraging. Now it is no longer moving upstream in the next generation software supply attacks. They are going after the supplier, right? They're very sinister attacks, and they're not waiting for public vulnerability disclosures. They're taking the initiative, injecting the vulnerabilities into the open source projects, so that these are going to be feeding global supply chain. And by the way, the underline is on global supply chain. In software, it's always global. That's why United Nations has gotten into the thing, and all countries are there because it impacts the entire globe, right? So now this is what they're doing. They are now from passive, they're moved into actively, attacking, right? And they're shifting their attacks upstream. Now by moving upstream, right, they get more time before the thing is detected. So they get an advantage of time, and they get an advantage of much more volume of customers downstream who get breached. So the same thing, instead of just focus, while these are closed, what they're doing is they're moving upstream and directly attacking open source repositories, right? Now, the next generation attacks are all about open source repositories. That means something that is outside the organization. And that's what makes, the internal vulnerability management program, non-effective, because the attack is completely out of the control of an organization. Now, how do they do this particular thing? And why open source repositories? Let's just try and understand the importance of this particular thing, right? In today's application development, a software coder, right, writes very little code, right? Only 3% to 10% maximum lines in a, say, if an application has got 100 lines of code, right? Just about 3 to 10 lines will be actually coded, written by the developer, right? 90 to 97 lines are just picked up from open source repositories, and they're combined together to form the application. And that is the modern way of application development. It's there across the thing, right? All applications are written in this way. Developers write a certain thing, and then they pick up open source repositories. Build servers are the ones that combine them together, like Jenkins and other things go there and pick up the particular thing, combine them both to create an application. So what happens if this is the thing, right? The attack is here it is very, very fruitful, because if you look at the open source repository, there are many, many open source repositories. I have highlighted 4 of them: Maven, NPM, Python, PyPy, and NuGet for this thing. This is for .NET, this is Python, this is for JavaScript, this is for Java, right? These are the top 4. If you see the thing, they have 37 million packages and components are there in these, which are being and 6.3 million new packages and components, code components were added in 21. 27 million developers downloaded 2.2 trillion packages from these places. Imagine, right, if they get compromised, how much of application is going to be compromised downstream, right? So these open source repositories are prime target. Now the thing is, all these 4 top ones have got huge number of vulnerabilities as it is, right? 23% of the Java repository, Maven, is all vulnerable code and packages. NPM 39%, JavaScript one, Python 38%, .NET. They already have vulnerabilities, which developers blindly get them down, combine it with their code, create an application, and then that application, the supplier gives it to the customer, right? And the customer suffers in the bargain. So anyway, this is what is the open source repository environment. Now, the next generation software supply chain attacks is purely using these four to open source to attack. And there are three techniques that these guys use to attack them. The number one is called dependency confusion. We'll see this very quickly, what these are, so that you have a clear understanding on what these are. Dependency confusion, TYPOSQUATTING, and malicious injection. These are the three attacks, right? Now, dependency confusion, this is day before yesterday, 4 days back, the report. 1,275, dependency confusion packages are there in the Python open source repository. So anybody who's downloading that particular thing, right, the chances of that guy getting his code being infected by a Trojan is almost 99%, right? Now, what is this dependency confusion? I have put out here a thing, right, so that you understand. When a developer writes code, right, his code is written in a code file. He types in the particular thing, right? And this is that 3% of the code that he has written out here. And he has a manifest file. Manifest file, he puts all the dependencies, right, which have to be picked up by the build server from repositories and brought together and combined, right? So that is what this thing are. So these are the dependencies. Now, if you see the thing, this is an actual manifest file of PayPal, right? And PayPal got attacked and breached by this particular thing. So we will see how PayPal got, and this is just about 6 months back, much after SolarWinds. So this developer wrote this manifest file and he said, PP logger, auth PayPal, and another WURFL and analytics. These four were in a repository which was internal to PayPal, right? It was an internal thing. Whereas open source repository, NPM, JavaScript, there nothing. None of these dependencies are out here. So the CISO and other things, they were quite confident, thinking that, okay, fine, we are not using any open source thing. All this code is within our own repository. So what does the build server do? Build server takes the manifest file and takes the code file and brings them and joins them up to build a thing. So what it does, first thing it checks, are any of these dependencies or thing available in a open source code repository? It checks this. If it finds from there, it will bring it. If it doesn't find, then it goes to the internal one and picks up that and the code file, combines them together, and the build and the software is built. This is how a build is created. Now what happens? This is attacked by the thing. The attacker puts a Trojan code in the NPM repository by the same name, analytics PayPal. Here it was 1.0. This is an actual attack, by the way. He put 2.0, which is a newer version than 1. He put it into that. Now, what did the build server do? The moment the code developer said commit, the build server checked out here, is any of these files available in the repository? It finds the same name out here. So what it does is it brings that one, and then from internal thing, the rest of the 3 it will pick up. Now, why it has picked up this and not this? Because the version is 2. So it is a newer version than this. So the build server feels this is the more later one. So it's picked this one and these three things, and the build has been made, right? This is how PayPal was like, this is the dependency confusion. So all that an attacker has to do is put these Trojan codes here with the same name as software which is internally. And using this, in the month of July of 21, 35 top companies of the world got breached, including Microsoft and Apple, Tesla, HP, IBM, and all of them got hit by this particular thing. The next attack is what's called type squatting. Now, in an open source repository, there are a number of packages. So these are actual package names. Okay, one is called Electron, other one is Load YAML, and these are the version numbers. So this exists in the repository. So what the attacker did was he added 2 more packages into the open repository, right? And he named it at Electron 10.2 and Load YAML without that hyphen 7.2. And these are Trojan packages. Now, after you put this thing, is now waiting there. Some developer is definite to mistype. Instead of Electron, types Electron, which is very common, right? Very, very common this. Moment he types this, the build server looks not for Electron, but Electron and brings the Trojan one into the thing and makes that software, right? So the software has got a Trojan in it, and that goes to the customer. There's a typo-squatting attack. The next attack is malicious injection. This is a clear, it's a very standard thing. You have every open source repository has an administrator or a group of people who maintain that repository, right? They're administrators, right? So suppose these guys are administering NPM, this particular code repository. So the attacker, does a spear phishing, traditional legacy attack, picks up the credentials of those guys, uses that credential to insert a Trojan to this thing. That same earlier one, that Electron, this thing, same name, now he has injected a Trojan into that particular thing. Once he does that particular thing, next time a build server picks up this thing, we'll get a Trojan one. So this is how he's injecting the malicious code. So these are the 3 next generation software supply chain attacks that have become these are what have moved it to 650% that we're talking about, right? So now how do you protect this, right? Let's come down to protection. So the open source repositories, right, are getting attacked because it is out there in the public, right? Under nobody's charge. So first thing is, don't let the build servers or the DevSecOps connect to the open source thing. Bring all the required libraries and code packages into an internal repository. When that is brought into the internal repository, first it is vulnerability scanned. There are these open source scanners, like Nessus. There are a number of pretty good, sanitize the thing. So when you bring those software components into the internal thing, right, you're sure that they're not Trojan. Once it is brought in out here, stop this particular thing. Don't allow DevOps build servers to go to the open, but pick up from the internal things. By the way, this is also required under the regulatory compliance thing. Like where we had gone through that thing where it says maintain, integrity, right? That integrity requires suppliers to create internal repositories. In Nissan, we had 3 internal repositories for different applications, automotive applications and IT applications. So, and this I'm talking about 8 years back, right? We had this particular thing sanitized well into the thing. And the build used to be only. So straight away, this attack vector gets protected against. Of course, the second one is you implement zero trust architecture for the rest of your thing and apply, and at a customer end, supplier risk management. Now, what is the supplier risk management here? Let's see this thing. 4 major areas. One is, now all these are related to the supplier. You need to maintain an inventory of the software. But this inventory maintaining, we have that CISO where the top 20, controls also says maintain inventory of software and maintain inventory of hardware. But that's more from the vulnerability management part of it. Here we are talking about maintaining an inventory of a detailed inventory, including the components of the software. Maintain inventory of the software, document the software support by the supplier. Does the supplier give patches? Are there email updates, like a regular email, contact, all those things? Why it's important to think? Because there are social engineering attacks that also happen where you might suddenly get a fake notification email saying that click this for a latest notification. That all that gets discovered if you know exactly what is the kind of support channels that the supplier has. Document the key processes that are supported by the software, because tomorrow if the software gets Trojan or whatever happens and you need to take it offline, right? What are the key business processes that are going to get impacted, right? You need to have a clear idea of that. And you need to have an idea and a plan to address, and have a response if the software has got a vulnerability, right? And how do you react to that? You need to have a response plan for that. So these are all the first group of risk management activities. The next one, and very, very critical, right, is gaining absolute 100% visibility into the software composition and the supplier's processes, right? Now you need to know, and by the way, by law now, regulatory compliance, the customer can ask, can demand, and the supplier from May of this year, they're supposed to be giving it. They cannot say no, right? The customer should ask for SDLC practices that are being followed by the supplier. What are the vulnerability management program processes that are in place in the supplier? What are the patch management capabilities which the supplier has? What third-party audit certification does the supplier has, right? And who are the approved list of suppliers of the supplier? Because then you can tell, you can also go further upstream and check from that supplier's supplier, right? So all these processes here. And then second visibility is you can demand for an entire software component inventory and the software bill of materials. As I told you, it's now become regulatory compliance requirement, right? That suppliers have to give the customers SBOM, that is software bill of materials, both as in a normal Excel kind of stuff and in machine readable form, so that now there are software which are being developed which will just ingest the machine readable BOM and keep tracking that any of the component which is in the BOM, right? Are there new patches for it? Are there any vulnerabilities discovered in that? So you basically are automating the entire thing at the customer end, so that even if the supplier doesn't tell you that there is an update and there is a vulnerability, you can, at the security level, the CISO's office can itself discover these things. Very importantly, if a supplier does not or cannot provide the component inventory, right, use that for as a differentiator for selecting other competing products, right? Now that is where is the bottom line. which will pressurize the supplier to start moving into this direction quickly. US, it's like now mandated. No supplier can work with any of the government, federal sector without giving these things. Now most of the most of the top suppliers are working with the federal government, and therefore if they have implemented for them, you can also now demand that because they already have that thing in place. Next is you mitigate. You need to have mitigation management, vulnerability management, which is your normal thing. Implement documented thing, harden the software. Many times suppliers say that you need to do these activities to harden the software. Many times this is not done. IT department doesn't do it. CISO should enforce hardening, right, as per the supplier instructions. Because apart from other things, your insurance, you lose your insurance if you don't harden as per the supplier instructions. And it's known that breach occurred because of unhardened or unpatched software. So harden it then. Now, many times suppliers also say that their software will use these IP addresses, these ports, right? If that is told by the supplier, make firewall rules such that any communication out or in to that software will be as per the IPs and ports which have been told by the supplier. Therefore, you can deny any attacker to send out DNS queries through and pick up data, etc. Incidentally, most of these places, right, today DNS attacks. DNS is the preferred way for people to be exfiltrating data, right? Because while we've been focusing always on port 80, right? The problem is port 53 is left completely unprotected. Nobody even looks at that. But the fact of that every DNS query that you make, 712 bytes of data can be sent out, right? And what they do is they repeatedly keep making DNS calls and keep sending about 700 bytes, encrypted bytes of your customer data or whatever which they picked up after a software supply chain attack and send it out. So you need to be very this vulnerability management program that we are talking about, focus on two things, right? Because that's the vectors that they're using. DNS, and second is SAML, right? SAML is another thing. Golden SAML attacks and other things are happening. So SAML and DNS are two things that you need to focus upon in your vulnerability management program. Next is monitoring endpoints and all that. That is remove unauthorized. Next is pre-identify alternate suppliers. You have Orion platform down because of SolarWinds thing. Who is your alternative? Where do you get another supplier? So pre-identify alternate suppliers, prepare failover processes, and conduct tabletoping. So these are the supplier risk management processes, right? These all have to be structured into a contract, a contractual document, legally binding contractual document with the supplier, right? And enforce this particular thing. So then zero trust implementation, I don't need to go into this. All of you all are well aware of what is zero trust implementation. But two important things: create your macro and your micro segmentations, and each of that segment should have an enforcement point. Have your and ensure that the identity of the user and the device, right, or what you call the non-person entity, is measured and converted into a confidence level, and authorizations are only given when the confidence level of a user or a non-person entity reaches above that threshold. So this is zero trust. I won't go into this part. Next is this part here, DevOps, DevSecOps, right? Your pipeline security controls you need to put into place, and automation. The name itself, pipeline, because today Software is like, it's like Ford old cars here, right? And it's a pipeline. It keeps going right from the time a code is written to how it gets like, committed, how it gets built and tested. It's all a pipeline. Attack points are there at every point of that pipeline. And CISOs should ensure that DevSecOps covers all those areas, right? Next is automation. As we saw that like automation is now required legally, regulatory wise also. You need to bring in that. Now, what is this pipeline thing? The pipeline is right at the outer end, of the thing is software, like, the DevSecOps team, the security team should be involved with the dev team to do a design review of the software that's going to be produced in the supplier, right? And then based on that, do threat modeling, which will give you an idea where the attacks can come up, where are the vulnerabilities that could be introduced by this software. And then training. These are three things out here. What you call the SCM stands for Source Code Management Platform, right? So before it goes into this part is where you do a design review, threat modeling, you do training of developers. It's critical because all the flaws of software start at the developers part because they don't write proper code, right? And if they don't write code, no amount of web application, firewalls, and secure gateways and other things will help you. Because the core, the heart of the software itself is like, vulnerable. So it's very important for training these developers to write proper code. And like, generally what happens is that in these areas, in the DevSec environment, the CISO initiates what's called as the security champion program along with the dev head, right? Now say, like we did, I did for Fidelity. There's security champion part. So, you train people who in turn will train other developers. Then you have, in the SCM part, before the code is committed into that, there's an automatic scanning of the code right at the developer's workstation itself, right? There are these ID-based scanners. After that, SAST and DAST is to be done right at the SCA thing. Code signing, which should be automatic code signing, not only at the last node. Every step of the pipeline, code signing should be done so that no modified code can be added into the thing. And then, of course, the platform security. Similarly, like you have the CI/CD controls. That means this part, there is software dependency security. Like here, this bad dependency can come in out here. So composition, open source vulnerability scans, software bill of materials, and internal repository. These are all here. And of course, each of that component is again code signed and secure. And then finally, you have the distribution things, penetration testing of the distribution platform. So this basically is the pipeline security part of it in the dev. Automation, like there's a final thing, automation. You automate the entire code security, like all the scans, SAST, DAST, everything should be automatic. It's not that like, security, the CISO team keeps doing a SAST or DAST every time. It should be all automated. The build server security should also be automated. That means software composition analysis and the open source vulnerability scanning. Every time the build server brings an open source component to make a software, before it builds, it should do a vulnerability scan, right, on that to see that there are no Trojans, etc. And then finally, the code signing should be continuous code signing. Therefore, you need to have key management, HSMs, allocation, revocation, etc. The whole thing should be automated. Now, here is one, I've just put one example. Like, in Nissan, how we had automated the entire, code part, SAST and DAST. Developers, decide what code is to be written. The moment the code is written, the SAST ID scanning is done and it's completely automated, right? Right in his workstation itself, he wants to send that into the the code server. Before that, a scan is done. All the vulnerabilities are pointed out to him. He corrects that, and then it moves into the continuous integration, the build server. Moment it comes out here, automatically it is sent there. SAST automation panel will do a SAST software analysis testing of the code, create reports which it has found. Then it moves back into the test environment. There it does the DAST, the dynamic testing software thing. Again, reports are generated, right? And then finally, when it goes into the production environment, again a DAST is done and report is written. And all these reports are picked up by the security champions and sent back to the developers to correct those particular things. And then the chain continues. This is all done automatically with no intervention of security at all. So that's it. Now, in conclusion, right, I just want to add this thing. Supply chain attacks are the most insidious, which we all have already spoken about. Right? They're dangerous because they're largely out of the organization's control and they're mostly unstoppable. They will be leveraged more and more by attackers, and we'll see more and more. 650% growth last year. This year, it's expected to cross over another 1,000% over and above that. Right? Now, for you to protect yourself, update your controls now. If your organization develops software internally, you must have robust DevSec processes, and you need to secure the entire CI/CD pipeline. You need to create an internal repository of software libraries. Sanitize the open code, source code before moving copies into the internal repository, and do not allow developers to access public open source. They should only go into the internal repository thing. That means your build servers must be configured to just only go to pointed to the internal repository. And if you are a customer, implement supplier risk management program so that you gain visibility into the supplier's processes and composition. And both supplier and customer must implement zero trust architecture, where you create macro and micro segmentations and authorize access to resource only after authenticating the user and device, and only if they're above the required confidence level. Thank you.